Sketch part A, f of x equals the square root of x, and h of x equals the square root of x plus 5, and g of x equals the square root of x minus 3. Okay, let's do the basic steps. Number 1, find the basic function. Well, the basic function that keeps varying in these three functions, f, h, and g, is the first one, f of x equals the square root of x. Okay, so let's remember what that picture looks like. The basic function is f of x equals the square root of x, and the picture has a point at the origin, 0, 0, and it goes off to the right. Step 2, h of x is given to be equal to the square root of x plus 5. So we're adding 5 to the evaluation of the function. That means we're going to shift 5 units to the left. Remember, when we add a number to the x value, we shift to the left. G of x is equal to the square root of x minus 3. When we subtract a number from x, we shift the graph 3 units to the right. It's always the opposite direction when you do things with the x value. Okay, so here's our graph. We'll draw our y-axis and our x-axis and put some numbers so we'll know what's going on. You always need to put a few numbers on there so I can follow your logic. On the x-axis, we have -5, -3, 3, and 5. Let's go up and down. Okay, the first function f has a point at the origin. That's just f of x equals the square root of x. Then the second function, h, that's shifted 5 units to the left. So we take that basic function, shift it 5 units to the left, and then the next one shifted 3 units to the right. So you see, go back and examine the definition of the h, f, and g function, the f being the basic function, and see how the variation, adding 5 to the evaluation of the function for h of x made us shift to the left. Subtracting 3 from the x values where we're evaluating the function for part g, for function g, made us shift 3 units to the right. Okay, let's go on to the next part. Part b, we have f of x is equal to x squared, and we're given h of x is equal to x squared plus 2, and then g of x is equal to x squared minus 3. Okay, so let's consider the basic function is x squared, and that function is just a happy face parabola centered at the origin, ... Okay, in other words, I'm saying it's not centered at the origin, it has a vertex at the ordered pair 0, 0. Now, what are we doing to h of x? H of x is a variation of f of x. Do you see that? All we did was that we added 2. If we add 2 to the outside of the function, we didn't evaluate h of x plus 2. We added 2 to the original f of x. So we're adding it to the y partners, which means we're shifting up 2 units. That's the same as saying h of x is equal to the original f of x, which was x squared, plus 2 more units we add to that upward. Now, g of x is the original f of x, which is x squared, minus 3. So we're going to shift down. We're subtracting it from the original basic function, f of x, so we're shifting down. Okay, so the picture, here's our y-axis, here's our x-axis. F of x equals x squared is passing through the origin, 0, 0, that's where the vertex is, and it's happy face. Then the second one, h of x, has a shifting, let's see, 2 units up, 1, 2, happy face. And then the last one has us shifting the vertex 3 units down. So that's all the functions, f, h, and g, graphed on one xy coordinate system. And for our last example, we have f of x equals x to the third power. G of x equals negative x to the third power. Okay, now the original function, the basic function, x to the third power, has a point through the origin, and then it looks like a little snake on each side of the origin. It looks like this. Now, if we are going to throw a negative sign in the front, that means we are taking our basic function f of x and putting a negative sign. We're multiplying in front by a -1. So what that means is we're going to change this function so it's a reflection about the y-axis. So instead of having the arrow on the lower left and the upper right, we have it on the upper left and the lower right. And if we graph those two functions together, here's our f function, and then the g function, which is just a negative of the reflection of the f of x. So it's good to examine this alongside of your write-up of the previous explanation of how variations to the basic function in the equation results in variations of the graph.